video I will solve paper 529701 Feb March 2024. Let's start. Question number 1. Seawater contains about this is very important to note each and every point in the question. Seawater contains 20 gram per dm cube of chloride ions. The exact concentration of chloride ion in seawater can be determined by titration with aqueous silver ions using aqueous potassium chromate as an indicator. Potassium chromate as an indicator. When aqueous silver nitrate is added to a sample of seawater, silver ions react with chloride ions to form precipitate of silver chloride. So this is the ionic equation of the silver aqueous to form with chloride aqueous to form silver chloride solid. So this is the precipitation reaction. When all of the chloride ion has reacted with silver positive ion aqueous, the presence of unreacted silver ion is detected. It means silver positive ion is in excess, so that's why it is unreacted silver positive ion is detected by chromate ions. A red precipitate of Ag2, red precipitate of silver chromate 6 is seen. So the unreacted silver ion then react with chromate ion, form silver chromate 6 in the form of precipitates. The amount of Ag positive reacting with chloride ion in the sample of seawater can be calculated in order to determine the concentration of chloride ions in the sample of seawater. A student uses the following method. Step 1. Use a weighing boat in which you have to weigh the sample. So this is the weighing boat. Just like this is the weighing boat. Silver nitrate by difference approximately 10.6 gram of silver nitrate into 100 centimeter cube glass beaker. 10.6 gram of silver nitrate into 100 centimeter cube water. Step 2. Use the sample of AgNO3 solid in the glass beaker to prepare 250 centimeter cube of AgNO3 aqueous solution. So first dissolve silver nitrate in this beaker and then transfer this solution with all washings in this conical flask, volumetric flask which is of 250 centimeter cube. Transfer this solution into dark brown glass. Now transfer this solution into dark brown glass. Label this X. This is bottle brown bottle labeled X. Collect a sample of seawater and remove any solid material present. Step 5. Transfer 10 centimeter cube of the seawater into the conical flask. Add 1 centimeter cube of potassium dichromate to the conical flask. Collect a sample of seawater and remove any solid material present. Transfer 10 centimeter cube of the seawater into the conical flask. Now take 10 centimeter and add into the conical flask. Add 1 centimeter cube of potassium chromate 6 aqueous to the conical flask, 1 centimeter cube with the help of pipette. Rinse the burette in the preparation for the titration. Fill the burette with the solution X. Slowly add solution X to the conical flask till the white precipitate turns red. This is the end point. So red because silver chromate 6 is red in color. So when it turns red or precipitate turns red, then this is the end point. Now describe how the student should carry out step 1. Include a table in your answer to show how this process is recorded. First, find the mass of empty weighing boat and empty boat plus silver nitrate, and then subtract the mass of uh, mass of silver nitrate from the empty boat. Mass of empty weighing boat gram is equal to x. Suppose this is x. Mass of the weighing boat plus silver nitrate is the, let's say it is, because silver nitrate gram taken is 10.6, let's say it is 13.0. So and weight of empty weighing boat, let's say that it is 3.0 gram, and mass of empty weighing boat plus AgNO3 is 13 gram, and mass of AgNO3 by subtracting this amount from this, so like 13.0 minus 10.6, sorry, minus 3.0. So the total mass is 13.6. So subtract 3.0 from 13.6. So in this way we get the mass of silver nitrate, that is exactly equal to 10.6 gram. Describe how the student should prepare 250 centimeter cube of silver nitrate in step 2, starting with the silver nitrate solid in the 100 centimeter cube of beaker in step 1. Dissolve 10.6 gram of silver nitrate in 100 centimeter cube of distilled water, 100 centimeter cube of beaker, and add with distilled water by using stirrer. Transfer all solutions in 250 centimeter cube volumetric flask including washings. Make up the solution up to the mass with the distilled water, or you can fill the volumetric flask up to the mark, like this is mark of 250 centimeter cube. So after transferring all washings in the volumetric flask, fill this bottle with distilled water up till this mark. So in this way, this is the solution of 250 centimeter cube. Suggest why solution X is kept in a dark brown glass bottle in step 3 rather than a colorless glass bottle. You know that silver ion is light sensitive. When it placed, silver ions reduced by light silver solid, so that's why brown bottle blocks sunlight. So prevent to reduced silver solid, this solution is kept in brown bottle. Suggest how solid material should be removed from seawater in the step 4 by filtration using filter paper. Identify the most appropriate piece of equipment that you would use to transfer 10 centimeter cube of seawater from the dark brown bottle to the conical flask in step 5. So pipette is used, 10 centimeter cube pipette is used to transfer 10 centimeter cube of seawater from the dark brown bottle to the conical flask. Add 1 centimeter cube of K2CrO4 to the conical flask in step 6. Micro pipette can be used to carry 1 centimeter cube of potassium chromate and transfer it into the conical flask. Question F is the chromate 6 solutions are known to be carcinogenic. State what precautions should be taken when using potassium chromate 4 aqueous in step 6 other than wearing safety goggles. Wear mask or use gloves. State what the burette should be rinsed within step 7 with silver nitrate, the solution which is taken in the burette afterwards. Age the student obtains the result shown in table 1.1. final burette reading. This table is filled, and you just subtract initial volume from the final volume, and you get the titer used in this titration. This is 23.40, this is 22.35 and 22.60. By subtracting this we get the volume. Now these two values are the best titration, 22.45 and 22.35. Look at the closer value which has less difference between two volumes, so those are the best titration. You know, this is 22.35 and this is 22.45, only 10.10. The difference is in between these two values is 0.10. So these are the two best titrations. So in the titration volume, the difference should be from not more than 0.10 to 0.20. So this is the difference between these two values is 0.10. So that's why these two volumes are used. Calculate the mean titer to be used in the calculations. Shows your working. 22.35 plus 22.45 divided by 2. The mean titer is 22.40. Use the mean titer from H2 to calculate the concentration of chloride ion in the sample of seawater. Assume the mass of silver nitrate used in step 2 was 10.62 gram. This is 10.62 gram. First calculate the moles by using mass over MR. So 10.62 divided by silver nitrate, the MR of silver nitrate is 169.87. The mole is 0.0625. So this is the chemical equation. Concentration of silver nitrate is equal to, so 100 centimeter cube volume look at here, use of being AgNO3 into 100 centimeter cube so this is step 2. Concentration 0.0625 is the mole and volume is 100 centimeter cube into 1000. So the concentration of silver nitrate is 0.625, and we know that the concentration of so in this way we can find out the concentration of chloride ion, silver nitrate which react with the chloride ion. So C1V1 is equal to C2V2, concentration 1, concentration of silver nitrate, volume of silver nitrate, and concentration of chloride ions and volume of chloride ion. So 0.625 is the concentration of silver nitrate into 100 is the volume, is equal to concentration into 250 in which 250 is the volume of the silver nitrate. 0.25 mole per dm cube. So it means silver nitrate, so we have 1:1 ratio, 1:1 ratio. So it means the mole of chloride is 0.25 mole per dm cube, sorry, yes. So the concentration of chloride ion is 0.25. so moles of silver nitrate which react with silver chloride ion, that is 0.245 is the concentration of silver chloride. So into 22.40 is the mean titer volume divided by 1000. So this is mole of chloride ion, 5.6 mole of chloride ion, 5.6 into 10 raised per 2 minus 6. The concentration of chloride ion is the mole over volume into concentration of chloride ion, 5.6 into 10 raised per 2 minus 3. This is the mole over volume. So the answer is so for example, concentration of chloride ion can be calculated like this, like 1000. So this is the concentration mole of 5.6 into 10 raised per 2 minus 3. These moles are in 5.6 into 10 raised per 2 minus 3 into 10 is the volume centimeter cube divided by 1000. So 1000 contain this mole, and what would be the mole in 10 centimeter cube of the solution. 1000 contain 5.6 into 10 raised per 2 minus 3, so 10 centimeter cube contain x.
अच्छा remember जो same line scheme है and the same stanza structure throughout the poem
of like this, 1000 contain 5.6 into 10 raised per 2 minus 3 and 10 centimeter cube contain x. So this is the concentration of chloride ion. Calculate the percentage error in the titer in the titration 2. So the percentage error, you know that 0.05 is the accuracy of burette, and you know that we calculate 2 times. Initial reading we have taken 2 readings in the burette, like initial reading and final reading. So that's why 0.05 into 10 into 2 divided by the volume, which is average of this average titer is 22.60 into 100. So the percentage error is 0.44%. Spectroscopic analysis of the sample of seawater accurately determined the concentration of chloride ion to be lower than that determined by titration with silver ion. Suggest why the student's method gave a higher value. More tighter value give more concentration, and more silver ions are consumed with silver as well as with the potassium chromate. So this is actually the reason that more tighter value give more concentration and more silver ions are consumed with silver as well as with potassium chromate ions. Question number 2. Students want to investigate the rate of hydrolysis of methyl methanoate. So this is methyl ester hydrolyzed to form methanol and methanoic acid. The reaction is catalyzed by dilute hydrochloric acid aqueous. The amount of methanoic acid produced as the reaction progresses can be monitored by titration with aqueous sodium hydroxide of known concentration using thymophthalene as the indicator. To determine this, the volume of sodium hydroxide needed to neutralize the H positive ion from the catalyst needs to be found beforehand. The student uses the following procedure. Step 1. Add approximately 150 centimeter cube of iced water to the 250 centimeter cube of conical flask. Let's say that this is the 250 centimeter cube conical flask. Add 150 centimeter cube of iced water in this, and label this flask as A. In step 2, add 200 centimeter cube of 0.250 mole per dm cube of HCl to a 500 cent. This is another flask labeled as B, and transfer 200 centimeter cube of 0.250 of HCl to a 500 centimeter cube conical flask B. Conical flask B is the flask in which the reaction takes place. Transfer 2 centimeter cube of 0.250 mole per dm cube of HCl aqueous from conical flask B to a conical flask A. Now transfer 2 centimeter cube of this concentration of HCl from conical flask B to a conical flask A. Carry out a single titration of the contents of conical flask A with sodium hydroxide of known concentration. Add 10 centimeter cube of methyl methanoate to conical flask B. Swirl the reaction mixture and immediately start a stopwatch. After 1 minute, transfer 2 centimeter cube of the reaction mixture from conical flask B into the conical flask A. Carry out a further single titration of the contents of the conical flask A against sodium hydroxide. Do not empty the contents of conical flask A between titrations. Step 6. After 10 minutes, transfer 2 centimeter cube of the reaction mixture from the conical flask B into the conical flask A. After 10 minutes, titrate the contents of conical flask A, which have 2 centimeter cube of reaction mixture from the conical flask B. So titrate it with the sodium hydroxide. Repeat step 6 at intervals of 10 minutes for 1 hour. State which step is used to determine the concentration of H positive ions from the catalyst in the mixture. Step 3. Because in this step 2 centimeter cube of 0.250 HCl from reaction B to conical flask A. Carry out a single titration of the conical flask A with sodium hydroxide.